Right, block P, mass 2 kilograms is connected to block Q, mass 3 kilograms by a light string. Both blocks are on a plane inclined at 30 degrees to the horizontal. Block Q is pulled by a constant force at an angle of 25 degrees. So you have an externally applied force here, and that externally applied force is at an angle of 25 degrees parallel to the surface. So that force is going to be broken up into components. So you're going to have a y component for that force and an x component for that force. So you just give me a second, please. Just 1 second. And then obviously you're going to have your gravitational force broken up into components. The incline is at 30 degrees and the applied force is at 25 degrees. And one more thing, you've got block P over here that moves over a rough surface as indicated there. And you've got Q that is on a frictionless surface. That means this is on a smooth surface there. An average constant frictional force of 2.5 newtons acts on block P. So your kinetic frictional force here is 2.5 newtons. There is no frictional force here because it's on a smooth surface. So I'm going to leave out the statement for Newton's second law. Draw a labeled free body diagram for P. So we're going to start off with P, but we're going to draw both P and Q. I'm going to draw the incline, but you're not allowed to do this. I prefer using components, as I told you. So there's my FG parallel, always acting down the slope. FG perpendicular at right angles. And then we fill in the rest. Your normal is in line with that. Your tension is going upwards. Badly drawn. And obviously you got a kinetic frictional force that's going to act downwards. Then for the 3 kilogram mass, which I'm going to just draw below this very quickly. You're going to firstly have your two components of your applied force. Fy and Fx. And then the usual forces that you have, which is your perpendicular component of your gravitational force, your parallel component of your gravitational force. There's no friction. There's a string over here. Please don't forget the tension force going backwards. And your normal force, that's going to be going vertically upwards. And there's all your forces on the two surfaces. This is the 3 kilogram. That's the 2 kilogram. And now we can go ahead and we can do the calculations. It says, calculate the magnitude of the acceleration of block P while block P is moving on section AB. That means it's moving upwards. So you want the acceleration of this moving upwards. If that moves upwards, this also moves upwards. They gave you 8 marks for that, which means there's a lot of working here. Definitely simultaneous equations. 15.3, we set up an equation for Newton's second law on the 2 kilogram. And again, forces pointing upwards are positive because it's accelerating upwards. The ones going down are negative. F net equals ma. Your F net there is going to be T plus minus Fg parallel plus minus your kinetic friction equals ma. Your tension minus mg sine theta minus the kinetic friction equals ma. We don't know the tension. That's 2 times 9.8. This theta here for Fg parallel is the angle of the inclination. That's sine of 30 degrees. The kinetic friction was given in the question. What was the kinetic friction? 2.5 newtons equals 2a. Can someone simplify this for me, please? Minus 2 times 9.8 sine 30 minus 2.5, that's 9.8, 11.8, minus 12.5. Minus 12.3, sorry. Please double check if that's correct. So T is 2a plus 12.3. Is the 12.3 correct? It is. That's your first equation. We then go to the 3 kilogram mass. It's a little bit more interesting. Again, F net equals ma. That's going to be your Fx plus minus Fg parallel plus minus the tension equals to m times a. Fx is F cos theta. This theta here is 25 minus Fg parallel is mg sine theta. This theta here is the angle of the inclination, which is 30 minus t equals ma. What was the applied force? 40. 40 cos 25 minus 3 times 9.8 sine, and this is the inclination angle 30 minus t equals ma. Sorry, the mass is 3. Can somebody work this out here, please, to at least 3 decimal places for me? Because I want to create a second equation now.
(21,552).
Minus t equals to 3a. Take the t across. 21,552 minus 3a equals to t. You got your 2 equations for t. You can now equate them to each other. 2a plus 12.3 equals to 21.552 minus 3a. 2a plus 3a is 5a. 21.552 minus 12.3. Divide that by 5 and you got your acceleration.
1,85.
Right, what did it say? Magnitude of the acceleration, acceleration, magnitude, so no direction. If block P has now passed point B, that means if it's past point B, there is no friction on it because P is going to be somewhere there. There's no friction on it now. How will the acceleration compare to that calculated in 15.3? Now remember, this Fx was previously overcoming this frictional force that you actually had over here, which you don't have anymore because you're now on a smooth surface, which means there is no backward force of friction acting on this block P. So you're going to have a greater F net acting on it overall because of the lack of the friction. Choose from greater than, smaller than, or equal to, and give a reason for your answer. Right, so 15.4, it will be greater than, and you're going to have a larger F net. And from Newton 2, your A is directly proportional to F net. Therefore, a larger acceleration. Boys and girls, I'm sorry about actually doing this. I would have actually continued to 6:30, but there's some writing in our area today, and I need to leave a little bit early just so that I actually use another route and get to school on time. So I'm going to actually end this over here. I will send you a recording of this last question here on inclined planes and Newton's second law. The next time we actually meet as a group, which would be now on Thursday, I'm going to use Newton's third law, some theory questions, and there is a calculation question like this here on Newton's third law as well. So please don't think that there's no calculation questions on this. Samir, where are you? Oh, I sent it to you. All right, people, thanks for attending this morning. And that's it. We are done with all the questions on Newton's second law now. For the rest of you that I'm going to meet today, I'll see you later on in school.
Right on.